The deep dive. We're tackling something, pretty frustrating today. A listener reached out about an Amazon EC2 instance that just won't boot. It shows that initialization failure message in the console.
Yeah, that's a common headache.
So we've dug into this. Our mission is to give you a clear, step-by-step guide to get that instance back online.
Exactly. Think of it like a troubleshooting checklist for your EC2s. We want to help you diagnose and fix it fast, so let's dive in.
Okay, step one, where do you even start looking when this happens?
Right, first place, always. The EC2 console output,
Mm-hmm.
or the serial console if you have it enabled. That's your window into what happened right at failure.
And what are we actually looking for in there? Like specific keywords?
Key things to spot are messages like kernel panic. That means a serious OS level crash.
Okay, kernel panic.
Yeah.
Bad news.
Definitely. Also, look for cloud-init failures. Cloud-init handles that initial setup, running scripts, setting host names. If that fails, the instance might stall.
cloud-init, right.
And finally, watch for errors about blocked devices, your storage failing to attach or mount properly. Those are your big initial clues.
Got it. So console output first. Kernel panic, cloud-init, or storage mount errors. Now, you mentioned cloud-init often runs user data scripts. Those can cause trouble too, right?
Absolutely. User data scripts are super useful, but yeah, they need care. First check. Make sure it starts with the right interpreter line, like #.binbash. Simple mistake, but happens.
Okay, check the shebang line. What else?
Be careful with commands that might just hang, like doing a big yum update or apt-get upgrade without the no-fila might wait for input that never comes.
Yeah, unattended commands need to be truly unattended.
Exactly. And crucially, check the instance's IAM role. Does it actually have permission to do what the script is asking, like accessing S3 buckets or other AWS services?
Right. If the script tries to do something it's not allowed to, it could just stop there.
Precisely. It just stalls the boot process.
You mentioned a pro tip for debugging these scripts. Something about set.
Oh, yeah. Add setx right at the top of your user data script. It's incredibly helpful.
What does it do?
Set E makes the script exit immediately if any command fails. Set X prints out each command before it runs, so you get a detailed trace in the console output showing exactly where it failed. It really helps pinpoint the problem command.
Okay, set XX. That sounds like a lifesaver for sure. Let's shift gears to storage, the block device mapping. What's important there?
You need to make sure the root volume, the main OS disk, is mapped correctly. It's usually something like devxvita or devsda1, depends on the instance generation.
So the system needs to know which disk is the main one.
Yes, and also confirm the EDS snapshot you built the volume from was actually valid. And if you have other EBS volumes attached, double-check their configuration too. Sometimes a secondary volume failing to mount can halt things.
Okay, check all the disks are mapped and valid. Now, something maybe less obvious, the instance type itself.
Yes. This catches people out. You have to ensure the Amazon machine image, your template, actually supports the instance type you chose.
How so?
Well, for example, the newer Nitro-based instances from AWS, they need AMIs built with NVMe driver support. Older AMIs might not have that.
Oh, okay.
And if you're trying to launch an ARM-based AMI, maybe for a Graviton processor, you must use a Graviton instance type, like a T4G or M6G. You can't run it on a standard Intel AMD instance.
Right. So the software template has to match the virtual hardware.
Exactly. A quick test is sometimes just trying to launch the same AMI on a different compatible instance type to see if that works.
Good tip. What if we've checked the console, the script, the storage, the instance type, and it still fails? How do we isolate this further?
Then it's time for some controlled testing. Try launching the exact same AMI again, but this time, provide no user data script at all.
Okay, strip out the automation.
Yep. And maybe use the simplest possible security group and subnet settings too, just to rule out network or script issues entirely.
And if that works?
Then you know the problem is likely in your user data or maybe network config. If it still fails even with no user data,
Then it might be the AMI itself.
could be, you could try launching a completely different known good AMI, like a standard Amazon Linux 2 AMI, just to confirm the basic infrastructure is okay. It's about narrowing down the possibilities.
Makes sense. Process of elimination. Now, for the really tough cases, there's this rescue procedure. Can you walk us through that? It sounds a bit involved.
It is a bit more hands-on, but it's powerful for deep issues. So first, you stop the broken instance. Don't terminate it, just stop it.
Okay, stop.
Then you detach its root EBS volume, the main OS disk.
Detach the disk, okay.
Now you launch or use another healthy EC2 instance, your rescue instance. Attach the detached volume to this rescue instance as a secondary disk, not the root disk.
Got it. Attach the trouble disk to a working server.
Exactly. Then you SSH into the rescue instance, and you can mount that secondary volume. Now you have direct access to the file system of the broken instance.
Ah, so you can poke around the files directly.
Yep. You can check log files in varlog, look at critical config files like etc.fstab for any weird entries, maybe check system unit files. If you made recent changes, this is where you might manually undo them.
Like fixing a configuration typo or rolling back a bad update manually?
Precisely. Once you think you fixed it, you unmount the volume on the rescue instance, detach it, then reattach it back to your original stopped instance, making sure you attach it as the root volume again, usually defs revolito or devs to 1.
Put the fixed disk back where it belongs.
Right. And then try starting the original instance. Hopefully it boots this time. It's like performing surgery on the disk in a safe environment.
That's a great analogy.
Okay.
So let's quickly recap for everyone listening. If your EC2 instance fails to initialize,
Start with the console output or serial console. Look for kernel panic, cloud-init errors, or storage mount problems.
right, then if you use user data, validate that script. Check the interpreter, watch for hanging commands, confirm IAM permissions, and maybe use setx for debugging.
Yep. Then verify your block device mapping. Make sure the root volume is correct, the snapshot was good, and other volumes attach. Okay.
Don't forget AMI and instance type compatibility. Nitro needs NVM, ARM needs Graviton, that sort of thing.
Crucial. If you're still stuck, try launching the AMI clean no user data basic network to isolate the cause. Or try a different AMI altogether.
And for deep issues, use the rescue procedure.
Yes.
Stop. Detach root volume. Attach rescue instance. Mount. Investigate fix. Unmount. Detach. Reattach as root to original. And restart.
That's the playbook. A systematic approach usually gets you there.
Definitely. So, final thought for you, the listener. Think about your own AWS projects. Which of these steps feels most relevant? Knowing these procedures before you hit a problem can really save you time and quite a bit of stress.
Couldn't agree more. Being prepared makes all the difference.
Excellent. Well, thanks for walking us through that super helpful stuff.
My pleasure.
And thanks to everyone for joining us on the deep dive. We'll catch you next time.